yesterday we have discussed different type of elementary operation and the corresponding elementary matrices. Mainly we have focused on row elementary operation, right? So similar thing can be do for column elementary operation and column elementary matrices also. Okay, so I think you have checked this thing, right? That you will get the same matrix. Okay, that 1 2 3 0 minus 3 minus 6 7 8 9. Okay, those students who have not sent the homework, don't tell me that why I am not getting the internal marks. Okay, so your class performance is most important, okay, for your internal marks. Okay, we have sent these are correct because you followed the class well, so no issue. Okay, so now we discuss the column operation. Okay, so let you have a matrix. Okay, 1 2 3 4. So if you apply some operation, column operation, okay, so suppose you are doing c1 dash is equal to c1 plus 2c2. Okay, so what you will get here, basically 1 plus 4 basically 5 and 3 plus 8, this is 11, 2 4. Okay, this type of thing. Okay, now like in your row elementary operation we have construct some matrix, right? That row elementary matrices that is of the form EI or EIJ or EIJC. These are the three type, right? So similar thing here also. Okay, the corresponding thing here we will say FI, FIJ, FIJC, like that. Okay, for example, this operation you will write F1 to 2, right, like earlier. Okay, now what should be the corresponding form? You will the corresponding form, you can say this will be your E1 to 2, its transpose. So what is this matrix? This is basically you know what is your E1 to 2, right? So basically 1 to position 2, so 1 to 0 1 and its transpose. So basically you will get 1 0 2 1, like that. Okay, now what is the difference in your row elementary matrices and column elementary matrices? So this operation, whatever you have consider here, that c1 plus 2c2, so this matrix you will get actually by multiplying this 1 2 3 4 into your this F1 to 2. Just check 1 2 3 4 into this is your 1 0 2 1. So what you are getting here, 1 plus 4, that is 5, 2 3 plus 8 11 and 4, right? So you are getting the same matrix, you see. So whenever you are doing some row operation and you will get the corresponding elementary matrices, that elementary matrices you have to multiply from the left, right? Here you have seen this example that you see this matrix, whatever you have, this is your multiplying from the left. Same thing whenever you are doing for column, you have to multiply from the right. Okay, so this is the thing. Okay, so your homework, to who have not sent the homework, you send yesterday and today's homework by tonight. Okay, so homework 2 is in I3, that is you are considering 3 cross matrix. Okay, write down the following column elementary matrices like F 3 1, oh sorry 1 3, both are same actually, just changing your first column and third column. Okay, then your F 1 2 minus 5 and F 3 7. Okay, this is the 3 operation. Okay, so these are the idea of your elementary matrices in your row and column both. Now can we say that the elementary matrices is non-singular? You know what do we mean by non-singular? Non-singular means a matrix is said to be non-singular if your determinant of A is non-zero, right? That type of thing you have learned in your class 12 level. Okay, so true or false? Every elementary matrices, maybe row or maybe column, are non-singular. You just think this problem and then send me. Okay, there are 3 types. You just consider all the thing and then you just check their determinant are becoming 0 or not. Remember that there are 3 type, right? So in the 3 type, yeah, in second one this is non-zero. Okay, if it is 0 then you will get the determinant 0. Check carefully. Okay, so these are the 3 type of row and column operation. Okay, next we are going to the next portion, that is a row or column equivalent matrix. Okay, row slash column okay. So what is a row equivalent matrix? Basically, first let's discuss row equivalent. Okay, then we will go to the column equivalent. Two matrices A and B of same order are said to be a row equivalent if one can be obtained from the other by a finite sequence of elementary row operation. Okay, so you have some matrix A, then you are applying a row operation, maybe more than one also, not any issue. Okay, so after that, whatever the output you are getting, that is, you can say that is row equivalent to the previous one. Okay, for example, suppose you have 1 2 3 4. Okay, then you are applying a operation R12. What do you mean by that? That basically 3 4 1 2. Suppose after that you are getting new operation. Suppose R2 dash is equal to R1 plus R2. I am just taking random some row operation. So R1 plus R2, what you have? R2 dash, so 3 4 4 6, right? This type of operation. Okay, now you see, already you have learned earlier that this matrix I can write as the corresponding R12 is actually E12, right? Network issue. So basically, suppose you have A matrix, after that you are doing some operation R12, then you are getting suppose some matrix B. Okay, then after that you are applying this operation that R2 dash is equal to R1 plus R2, you are getting the matrix C. So earlier whatever we have discussed, from there you have an idea that this matrix B I can write as E12 into A, right? And similar, we can have this C equal to your E121 into B, right? So from there you have E121 into E12 into A, right? So you have this property, right? So this matrix actually you will get that this elementary operation is always your non-singular. Okay, you just check this for each one. So basically the product of the two operation is again a non-singular, right? So from there you are getting some non-singular matrix P into A, right? Or P is a product of some elementary row operation. Okay, so if you able to write this some matrix, if you have A and B2 matrix, so it will be, so basically if you have a matrix A and B is said to be row equivalent if there exists a there exists a non-singular matrix P basically this is basically product of row elementary matrices, right? Elementary matrices. Such that A equal to or B equal to P into A. Is it clear? So if you able to write, so then you can say these two matrices are row equivalent. So you can say this matrix and this matrix also row equivalent, right? This is also row equivalent. Okay, because you are getting that matrix after applying some row elementary operation. Okay, now similarly if you do for column, so what will be changed? I am just copy this thing. Not so much change, just simple change. If you have column equivalent change, so a same order is said to be column equivalent if one can obtain from the other by finite sequence of elementary column operation. Okay, and in mathematically if you say so mathematically A is and B is said to be column equivalent if there exists a non-singular matrix. Suppose I am writing Q, product of column elementary matrices such that B equal to A into Q. Remember, column elementary matrices is multiplied from the right side. Okay, so this is the change. Okay, so this is your row and column equivalent matrix. Next thing is your echelon matrices. Most of the popular is your row echelon matrices. Okay, row. Basically we are comfortable with row operation, not column operation. Okay, row echelon form. So still now you have just learn what are the type of operation. Now you will learn why you have to do that operation. Already I have shown a example that you have some matrix, after some operation you are getting that identity type, right? So you have to make that. Okay, that should be your goal. Okay, now I am defining what is the row echelon form. Okay, sometime there are some short form. Short form. Okay, yeah, REF, just short form. And whenever it is row reduced echelon form, that will do next. So that is RRRF. Okay, anyway, so what is the echelon form? A matrix is said to be row echelon form if it satisfies one, all 0 rows, obviously if any, if it have are at the bottom. Second, the first non-zero entry, that type of element is called actually pivot. Okay, of each non-zero row is to the right of the pivot of the row above. Okay, third is your all entries below a pivot are 0. Now I will explain each point. Okay, so suppose you have some matrix. Okay, then if it is have some 0 rows, that should be in the bottom. Okay, so suppose you have 1 2 3 0 0 0 4 5 6. If you have this type of thing, so this is not in row echelon form. Why? Because the 0 rows are not in the below. Okay, so what you have to do to transfer this into row echelon form? First you should transfer your row 2 and row 3, right? So just using your swiping R2 and R3, right? This type of thing. Okay, so you have this one 1 2 3 4 5 6 0 0 0. Okay, this is you have. Now you see, what is pivot? The first non-zero entry of each non-zero row. Suppose this is your first row, this is a non-zero row. So what is the first entry? Obviously this one. So that type of element is called what? Pivot, right? So according to the third property, you see all the entries below the pivot are non-zero. So obviously you have to make this type of element should be 0, right? So you need this type of operation, that R2 dash will be R2 minus 4 R1. So what you have? 1 2 3, then 0 5 minus 8 minus 3 6 minus 12 minus 6 0 0, right? So this is your so you can say that this pivot element 1 is satisfying the third property, right? Now you see, we have not still discussed the second property. What is the property? The first non-zero entry, or you can say the first pivot element, is to the right of the pivot of the row above. So basically what it is say, you see, for the second row the pivot element is will be this, right? Minus 3. So below this also you have that element 0, no issue. So it is saying that the first non-zero entry pivot of the non-zero is the right of the pivot of the row above. So basically you see this minus 3 and this 1, these are the two pivotal pivot element, right? Now you see the above row will be right of that one. So you see, whenever you are going from here to here, so obviously 1 is on the sorry, minus 3 is the right of your 1, right? This is it is saying. So you just check the first non-zero entry of each non-zero row is the right of the pivot of the row above. Okay, so minus 3 is the right of your previous pivotal element. So whenever you have this type of thing, always the pivotal element will be on the right. Okay, if you here you have 0, so if you have some element here, so no issue there. Okay, in this way. Now I am writing some matrix. Okay, and we'll discuss this type of matrix are in row echelon form, that is REF or not. Okay, check the following are REF or not. Okay, so suppose you have a matrix one, 0, 0, 2, 0, 0, sorry, one, 2, minus 1, 0, 2, 5, 0, 3, 1. Okay, minus 1, 0, 0, 1, 3, 4, 0, 0, 2, 5, 0, 0, 0. Okay, so I'm just taking some random example. Just check for the first one. Is it REF? You see what is the first non-zero? So obviously this one. So first pivotal element this, below of this all are 0, no issue. Next, what is the next pivotal element non-zero row? So you can have this one. So this is your third will be your next pivotal element, right? But below of that should be 0, so that's why this is not, right? Because this is non-zero element. Now next one, you see second one, this is your first pivotal, below at 0, no issue. Here also you have the same issue, right? Below of that should be 0, so this is also not. Okay, next you see here first pivotal, this one, below of this everything is 0. Here you have 1, below all the thing are 0. Okay, and this is on the right of that, right? So no issue. And this is also pivotal, below it is 0, and all the non-zero 0 rows are below of the matrix, so this is correct. For the this one, you see this is your pivotal, right? So only one pivotal element, so nothing you have to check, and the third property is satisfying. So this is also REF. Okay, so in this way you have to check. I'm just checking if there is some okay. So this is your REF. Okay. Rank of the following matrix. Okay. So here you have just two example. This one, and okay, you just check which are REF or not. Okay, in this way. Okay, now I'm going to the next one, that is your RREF. Okay, so basically they will provide you some matrix and they ask you change into the REF or RREF, like that. Okay, so this REF is you see there are maybe number are some any unit like 3, 5, this type of thing. So whenever you have RREF, all the pivotal elements should be actually 1. So here actually you see 3, 5, this type of thing element is coming, but you have to make that are also 1. Okay, so here I am writing what is your row reduce echelon from matrix, that is your RREF. Okay, so what is this matrix? That a matrix is said to be RREF if 1, it is row echelon from second, each pivot is equal to 1, third, each pivot is the only non-zero entry in its column. So what is changed here? You see, it is on row echelon form, so all the property in your REF, so that is in RREF also. Okay, next is your the pivot element, whatever you have, that type of element should be 1. So you see, this element is your I am highlighting this one. Okay, so this is your REF, right? So whenever you have to make this is on RREF, so what modification you have to do? First you have to make this 2 should be 1, because this is also some pivot, right? And so this is your, you can say this property, that each pivot is equal to 1. Next one, each pivot is the only non-zero entry in its column. What do you mean by that? So basically if this is a pivot, so this should be a only non-zero element in the column. So basically you have to make this type of element also 0. Okay, so you have to take care of that fact also. Okay, this you have to make 1, and then you have to make this element also 0. In this way you have to make this. Okay, anyway, so using your row elementary operation, they will provide you some matrix. You have to make it on RREF form. Okay, so okay, just tell me, is it in RREF? One 0 0 2 0 1 0 minus 1 0 0 1 3 0 0 0 0. Okay, you just check this is REF not. Okay, when you write the homework, okay, you just write this matrix and just say this is REF or not, in this way. Okay, okay, in RREF form. Okay, suppose I am giving you a matrix. What is it? 1 2 1 2 1 minus 1 1 5 4. Okay, you have to make it in RREF form. So operation you have to make. So first your target should be these two things should be 0, right? So you are doing, suppose R2 dash will be R2 minus 2R1. Okay, R3 dash it will be R3 minus R1. Okay, so what you will get, no change in your first one. So 2 1 minus 1, so basically this will be 0 1 minus 4 minus 3 minus 1 minus 2 minus 3, this is also 0 5 minus 2 3 4 minus 3 3. Okay, this you have. Next, what you have to do, basically our target should be, this should be 1. Okay, so R2 dash should be R2 by minus 3. So what you have, 1 2 1 0 1 1 0 3 3. Now what is your goal? Your this element and this element should be 0, right? So what operation you need, R1 dash will be R1 minus 2R2. You see, whenever you make this thing 0, so there will be no change in your this element, right? So that is the advantage. Okay, now if you, whenever you are practicing many problem, so you can apply two operation together. Okay, so R3 dash will be your R3 minus 3 R2. So if you do this thing, so what you have, 1 0 1 minus 2 minus 1, right? 0 1 1, and then you have 3, so 0 0 0, right? This type of thing you are getting. Okay, so this is already have done. You see, now it is check this is on RREF form or not. This is your first pivotal element, this is your next pivotal element, it is on the right, and all the 0 row are on the below of the matrix. So you have completed on the RREF. Okay, that's it. So in this way you have to practice more problem. Okay, Okay, so your homework 4 is your convert into RREF. So remember, every RREF is your REF, right? Because RREF is your more special. So if you convert into RREF, so no problem if they ask for REF. Okay, so this is some big matrix I am giving you. So 281070 minus 3 minus 12 is 0 2 2 0 5 20 minus 2 1 0 0. This is your first one. Okay, second one is your 1011 11 minus 1 2 20 10 0 minus 1 1 minus 3. Okay, so these are your homework. So basically you just see from the beginning. So what we have discussed in 2 classes, basically elementary operation we have discussed. Next, what are the elementary matrices. Okay, this is your homework 1, right? We have done, so you don't have to send the homework 1 again. Okay, so this is your homework 1. Then after that, this is your homework 2 for your column elementary officers. Okay, this will be your true. Okay, this is not your homework, so you just check. And then you have row equivalent matrices we have discussed. Next, what is column equivalent matrix, then row equivalent form, that is REF, which is not on, which is your REF or not. This is your homework 3. Okay, so this is also part of homework 3. Okay, and next is your homework 4. This is your last. Okay, so I am ending this class. Okay, your deadline is by tomorrow. Okay, because this will be a little bit lengthy. So 21 is the due date. Okay, I take the next class on 22. Okay, bye.